3.5 graphing techniques, transformations. So transformations, it's just like in 3.4, the library of functions. They are super useful, but you don't need to use them. But knowing them, of course, it's going to cut time significantly. It will when you get later on in calculus and stuff like that. But is it mandatory? No. Useful, helpful? Absolutely. So I know this is not the first time you've seen transformations, and now we're going to talk about them again, and we're going to find domain and range of each. So we're not going to explicitly graph them, but I will walk you through them. So vertical shift up. We're going to use the graph f of x equals square root of x to obtain the graph g of x equals square root of x plus 2, and then we're going to find the domain and range. Okay, so the white graph is called the parent function because it's before you do anything. It's before you add, it's before you subtract, it's before you multiply, before you divide. That's called the parent function. So if you wanted to use transformations, you need to memorize that right there. Honestly, although I would memorize roots, I would actually memorize 4, 9, 16, because we know the square root of 4 is 2, square root of 9 is 3, square root of 16. So that's what I would actually memorize. But yeah, you would have to memorize those values for the parent function. Then, after you know those values, you would have to remember that if it's a plus 2 on the outside, every point goes up 2 units. And that's how we get these values right here to the right. So the black graph represents square root of x, and the blue graph represents square root of x plus 2. Blue goes with blue, black goes with white. So do you notice that the black graph, which is the parent function, we just go up 2 units. Everything just gets shifted up 2 units. And that's our transformation. So let's talk about domain. Remember, domain is what x is. So x on our blue graph, it starts at 0. And it goes to the right, so that's positive infinity. Now for the range, we're talking about y's. So the smallest y is 2. And the graph, it is going up slowly, but it is going up. So since it is going up, it's 2 to infinity. All right, let's talk about vertical shift down with the same exact graph. So we're talking about square root of x, but let's do square root of x minus 2. So do you notice that every point, it just goes minus 2? So it's just minus 2 to every point, and that's how we get the next value. So every point, it just shifts down 2 units from the parent graph. Let's find our domain and range. So domain, how we find it is exactly the same way. We look at the smallest x of the blue graph. The smallest x is 0, and it's going to the right, so that's positive infinity. And then our range, our smallest y is negative 2, and the graph is going up slowly. It's going up, it is. So since it's going up to positive infinity. Vertical shifts. If a positive real number k is added to the output of a function y equals f of x, then the graph of the new function y equals f of x plus k is the graph of f vertically shifted up. And then same thing, but if it's a minus, you shift down. So meaning, what this means, like what the heck does all that mean? It's when you have a number not touching or inside parentheses with x. Sorry, I'll move that back. So it's when a number is not touching or inside the parentheses with x. So like those some examples of that is like y equals 2x plus 1. You see how it's not inside parentheses with the x? Or y equals x minus 1 squared. 1 squared plus 4. So you see how it's not inside the parentheses, it's not touching the x. So this would actually go up 1 unit. This would go up 4 units. So that's what it means by that. All right, horizontal shift to the right. So it's always opposite for left and right shift. So we want to graph f of x equals absolute value of x and use it to get g of x equals absolute value of x minus 2. So again, you would have to memorize all of these values. Then you were to graph it. And then after that, you would shift to the right 4 units. So since it's minus 2, it's to the right 4 units. Or excuse me, I meant 2 units. So we go plus 2 units, or right 2 units, right 2 units, right 2 units, right 2 units. We do the opposite. So it's plus 2, plus 2, plus 2, plus 2, plus 2. Same reason as circles, because it's a negative function. That's why. It's the same reason as circles. If you're like, what do you mean? Go back to circles in 2.4 and review that. Alright, so we have our black graph, which represents the white numbers. The blue graph represents the blue numbers. So do you notice just everything gets shifted to the right 2 units, and that's our graph. So let's find the domain. So the domain, since we have double arrow pointing up, our domain is negative infinity to positive infinity. This looks like a parabola, so treat it as such. Our range is smallest y is 0, and it's going up to positive infinity. If it looks like a U, treat it like a U for domain and range purposes. Alright, if the argument x of a function is replaced by x minus h and h is greater than 0, the graph of the new function y equals f of x minus h is the graph f shifted horizontally right h units. And if it's plus h, it gets shifted to the left h units. So an example of that would be like y equals x minus 3 squared, and this would be, so we would shift right 3 units. An example of the other way would be x plus 3 squared. You don't need the squared, it's just an example. So we would go left 3 units. That's what that's saying. Let's combine shifts. So here, I'll draw the parent graph. I'm going to draw it in gold. So the parent graph is 0, 0, 1, 1, and 2, 4. Oh, I don't need 3 points, it only has 2. And then opposite side, we have negative 1, negative 1. Okay, so that's the parent graph. Now let's look at our shifting. So here we have a minus 3 to the x. So since we have that, we're going to go right 3 units. Then, since this is on the outside, we're going to go up 2 units. So every point we go right 3, up 2. So we're at this point, we go right 3, up 2. Now we have a new point. Keep going. So the next point here, we go right 3, up 2. Now we have our new point. Last one, we go right 3, up 2. We have our new point. And then from there, you would just connect those dots. This is a parabola. So the domain is all real numbers. Now the range, it's since it's pointing up, you're smiling, you're happy, you're positive. And our smallest y, so in the blue graph, our smallest y is 2. And that's our range. Alright, vertical stretch. So we're going to use the graph f of x equals square root of x to obtain g of x equals 4 times the square root of x. So we're multiplying 4 to the output. So do you notice it's times 4 times 4 times 4 times 4, and we get those values? So that means we're going to grow and stretch by 4 units. So our apparent function, we're going to stretch it times 4. And that's our parent function. It doesn't ask for domain and range, so we're not going to do it. All right, a compression. So a compression is just the opposite. So to compress means to flatten out, right? So when you flatten something out, it gets closer to the floor, it gets closer to the x-axis. When you stretch, you're going up, so it's going to get closer to the y-axis. Do you notice that the dark blue graph, it's closer to the y-axis now? Because we're stretching. And for the compression, do you notice the blue graph, it's closer to the x-axis now? It's because we're mushing down. So do you notice every point, since it's 1/2, we just half every point, so we times it by half, or divide by 2, same thing. And that's all we're doing. So half of 4 is 2, half of 1 is half of 0 is 0, half of 1 is half. So that's what we're doing. We're just halving our y values. So we plot the new points. All right. How do we know if it's a compression or a stretch? So here, it is a compression if it's a decimal or a fraction attached to the x. So just like here, how it was attached to the x, and here it is attached to the x because it's 4 times. And then it's a stretch if we had y equals ax, if a is greater than 1. So it's a whole number greater than 1. So it's a whole number greater than 1. All right, all the second part is, it's just a repeat of what I just said, but I explained it perfectly, and I'm not going to go over that. All right, reflection. So graph the function f of x equals negative square root of x. We're going to find the domain and range. So it's not attached to the x, right? It's not. So since it's not attached to the x, the opposite of x is y. So do you notice that's what's happening? The y's are getting changed because it's reflection about the x-axis. What's the opposite of x? Y. See how it ties into symmetry? It all ties together. Cool, right? So all we do is flip it over the x-axis, or we switch every value to the opposite sign. Our domain, we find it the same exact way. So the blue graph, it's going to the right, so it's 0 to infinity. And the range, it's pointing down now. So if you're down, you're negative infinity, and our smallest y is 0. So when a function in f is multiplied by -1, the graph of the new function y equals negative f of x is the reflection about the x-axis of the graph of the function f, meaning you change the y, you flip the y. All right, reflection about the y-axis. So do you notice now that the x has the negative? So opposite of negative x, we're going to switch, opposite of y, we switch the x. That's why the x is negative for reflection about the y-axis. So it's essentially like a very similar problem, an example, but just knowing how to apply it, that comes in example 9. So our graph flips about the y-axis. So the black becomes the blue, and we're going to plot our points. So the domain, since I have double arrow pointing up and pointing down, left and to the right, my domain is all real numbers. And for the range, since I have double arrow pointing up and pointing down, the range is all real numbers. Reflection about the y-axis. When the graph of the function f is known, the graph of the new function y equals f of negative x is the reflection about the y-axis of the graph of the function f. Okay, example 9 is what's going to be on the test and what your homework is about. It's like 4 or 5 questions just doing stuff like example 9. You don't have to graph for 3.5 at all for 3.5, no graphing. Alright, so find the function that is finally graphed after the following transformations are applied to y equals square root of f of x in the order listed. So this is what we're starting with. So the first thing we need to do is shift up 10 units. So I want to take the given function and shift it up 10 units. So to do that, 10 goes on the outside of x, because a shift up, it's not attached to the x. Because remember, up is y value, so it has nothing to do with x. Alright, the second thing we want to do, so now we're coming from 1. Now we're looking at 1, and we're going to continue on from there. We're going to reflect about the x-axis. So opposite of x is y. So I'm going to make it negative y equals square root of x plus 10. I'm going to simplify. So just switch all the signs. So negative becomes positive. Positive becomes negative, and positive becomes negative. Alright, now that we did that, let's move on to our third thing. So now we're coming from 2. So now we're looking at this one right here. So now this is what we're working with, and I want to reflect about the y-axis. So the opposite of y is x. So I'm going to switch the x. So we have y equals negative. I'm going to switch it to the x to negative x minus 10, and that is our function. Since it says function, my bad, we have to do f of x. So after doing all of those transformations, the equation that we come up with is negative square root of negative x minus 10.